All right, in this video we're going to go over Chapter 4, Section 3, right triangle trigonometry. We've already talked about SOHCAHTOA, so this should all be just like a refresher or review. Normally if we're in class, this is one of the first sections that I do out of order. I usually do this one first. But okay, so like I said before, right triangles are here, 90 degrees. That means these other two angles have to add up to 90 degrees. The longest side is always called your hypotenuse. Then you have your adjacent. This is the adjacent according to wherever theta is. So if theta was up here, adjacent would be this side. Since this is the theta, adjacent's the one next to it, opposite's the one across from it. Okay, so let's go ahead and do this one. Sine, this is where I was saying the SO, S-O-H, CA, C-A-H, TOA, T-O-A, okay? Opposite, hypotenuse, and adjacent. All right, so if we look at this triangle here, here is our angle. We can actually label this. This will be our H, hypotenuse, because it's the longest side. Opposite would be over here. So I'm going to just put O equals 7, and then adjacent to this angle, that would be this one. So I'm going to put A here. All right, now all we're going to do is go across here and look at them. Opposite, that's 7, hypotenuse, 25. So this will be 7 over 25. Okay, adjacent, 24 over 25. Opposite over adjacent, that's 7 over 24. Hypotenuse over opposite, that's going to be 25 over 7. Hypotenuse, that's 25 over 24. And then cotangent is adjacent over opposite, so that's 24 over 7. Okay, so this is the SOHCAHTOA. Right. Next part, here we're going to do a couple of problems. This is saying, first use Pythagoras theorem to find the length of the missing side. So here we're only given two sides. The only reason we can use Pythagoras theorem is because this is a right triangle. Now, you also have to remember that it's a squared plus b squared equals c squared. C squared is always going to be the side opposite of the 90 degrees, or the longest side. So in this case, c squared, or c would be 4, and we're squaring that number. It doesn't matter which of these is going to be your 3. I'm just going to assign it to the a, so I'm going to put 3 squared plus b squared, and we'll call that b. So all we're doing is solving. 9 plus b squared equals 16, minus 9 from both sides. We get b squared is equal to 7, which means b is going to be equal to plus or minus the square root of 7. Okay. All right, then it says find the exact values of sine and cosine. Well, notice that it's telling us this is our theta. So this is going to be the side we're actually referring to. So let's go ahead and do this. This is going to be h. Opposite is going to be the b. So the square root of 7. And adjacent will be the 3. Okay, so we'll do it like that. Let's go ahead and do sine. Sine of theta is opposite square root of 7 over hypotenuse. Okay, and that's your answer. All right, next one, cosine. Cosine of theta is adjacent 3 over hypotenuse, which is 4. Okay, and you're done. All right, next one, it says, given an acute angle, if tangent theta is this over this, then find secant theta. All right, here's another one where we're going to have to go ahead, and I'm always going to do this. I'm always going to recommend that you draw your triangle, so let's go ahead and do that. Remember, if you have tangent, tangent is going to be opposite over adjacent. So I'm going to go ahead and put opposite here, and I'm going to put adjacent there. Let's draw our triangle. Okay, I usually draw it in the first quadrant. It will be good for you to do that. We'll also learn why this could be in actually quadrant 1 or quadrant 3 later. Okay, but draw it in quadrant 1, especially if this is a positive value. All right, so we're going to assume theta is right here. Okay, so opposite of this angle is going to be 5, and adjacent to this angle will be 12. So now we're going to use Pythagorean's identity or theorem to determine what the hypotenuse is. So let's go ahead and do that. Okay, a squared plus b squared equals c squared. Okay, this will be c. So we have 12 squared plus 5 squared equals c squared. 144 plus 25, c squared. 169, c squared. So c is going to be equal to plus or minus 13. We're going to consider it to be positive. So here's going to be 13. Okay, so according to this angle, this will be our opposite. This will be adjacent, and of course this will be our hypotenuse. Okay, so now we have all of those. Let's go ahead and find secant. If you don't remember what secant is, go ahead and come up here, but these are ones that you want to learn as soon as possible. Secant is hypotenuse over adjacent, so I'm going to go ahead and put that here. Secant is hypotenuse, which is 13, over adjacent, which is 12. All right, let's go on to the next one. Okay, so on this particular one, we already kind of talked about these. I'm going to go ahead and do this one for you just as a, I didn't draw this out before. This one, I did draw it out before. If you remember on our previous notes, I kind of did this here, and I came up exactly with the same information as we did here. This is using the original one that we have here. Okay, and then I broke it up into this one. Either way, it's going to work. So let's go ahead and do, first we'll start with the 30 degrees. So 30 degrees is right here. Sine is opposite over hypotenuse. So sine is going to be 1 over 2. Okay. For the next one, we're going to go ahead and do 45 degrees. Sine, so here's the 45 degrees. Sine is opposite over hypotenuse. Now here you have 1 over the square root of 2, but remember we don't like to use irrational numbers in the denominator. So when we rationalize it, it's going to come out to be the square root of 2 over 2. Okay, 60 degrees, well here's our 60 degrees, opposite over hypotenuse. So this is going to be the square root of 3 over 2. Okay. All right. Next part, cosine, is going to be adjacent over hypotenuse. We're going to start with 30 degrees. So adjacent is going to be right here, square root of 3 over hypotenuse, which is 2. Okay. For cosine of 45 degrees, it's going to be adjacent, which is 1 over the square root of 2, which is exactly the same thing. So we're going to rationalize it to also be the square root of 2 over 2. And then cosine of 60 degrees, cosine of 60, adjacent, that's the 1 over hypotenuse, which is 2. Okay, so all they're showing you here is that if you look at the numerators, you have 1, 2, 3. If you imagine this being the square root, it'll all be the square root of 1, square root of 2, square root of 3. Square root of 1 is just 1, so that's why they're using the 1, 2, 3. Same thing here, 3, 2, 1. Okay? All right, and then here's the rest of the table that they use to find out all of the other trig functions. Now remember, once you're done with these and you go over to these, all you're doing is taking the reciprocal. You're just flipping the 1/2. It now becomes 2. You're flipping this, so it's going to be 2 over the square root of 3, but then you have to rationalize that 3, and then you're flipping it. Okay, so that's all you're doing with these. Okay, and you'll see those exact values on your unit circle. Okay, so those are the exact values. Here it's saying find the exact value without using the calculator. Well, we don't have to use a calculator. We can use the unit circle, or first thing we're going to do is evaluate what is tangent of pi over 3. So here's pi over 3. Tangent, remember, is going to be your sine or your y over your x. Here, I know it's a little bit fuzzy, but it's going to be the square root of 3 over 1, or in other words, just the square root of 3. Okay, that's the first one. Going on to the second one, it says secant pi over 4. So again, you're coming over here. Secant is the reciprocal of cosine. Cosine is x. So if I flip this, I'm going to get 2 over the square root of 2. So this is going to be, let me put it over here. Secant of pi over 4 is going to be 2 over the square root of 2. But remember, we don't like to have it in this form. We can't have the radical in the denominator, so we're going to rationalize that denominator. This now becomes 2 square root of 2 over 2, and the 2's cancel out, so you're just left with the square root of 2. You'll eventually get to be good at these, so you don't have to rationalize those all the time, okay? Just for right now until you get familiar with it. So there you go. There's our answer. Let's go ahead and evaluate the next one. Okay, cosecant of 30 degrees. Well, here's 30 degrees. Cosecant is the reciprocal of sine. Sine is y, so all I'm going to do is flip the y value. Instead of saying 1/2, I'm going to say it's 2 minus, this 2 will come straight down, and then I have to evaluate sine of 45. So 45 degrees, sine is your y, square root of 2 over 2. So I'm going to do square root of 2 over 2. Now you notice that these 2 cancel, and I'm left with just 2 minus the square root of 2. And that's your answer. Okay, these shouldn't be terribly difficult, but it is really good practice that you're able to evaluate these trig functions. Okay. All right, let's go on to the next page. Okay, all of these identities you're going to have to be able to know, including Pythagorean's identities. Now, I will show you in Unit 3 how to go from one to the other, okay, by just knowing the first one. But it's good for you to be able to know all of this information. Okay, so I'm going to go ahead and talk about cofunctions now. Cofunctions are actually something that we've already started to discuss, but we hadn't discussed it in specific details. Let's go back to this one, and we're going to say, have we noticed that this angle right here and this angle right here are the exact same values? This is, all right, even though we're looking at different angles, when I'm over here and I say opposite, I'm actually looking at this number. But when I'm at 30 degrees over here and I say adjacent, I'm looking at this number. So these two square roots of 3 are referring to the exact same one, just from different points of view. From the 60 degrees, it's called our opposite. But from the 30 degrees, it's called our adjacent. That's why we have the exact same numbers here. Now the 2 is going to be always over the hypotenuse, which is not going to change. Just the only one that changes is the one opposite and the one adjacent to the angle. Okay, these are called cofunctions. Notice that this is 90 degrees. That means these two angles have to add up to 90. So if I look at these two angles here, they do add up to 90. If I look at these two here, they're exactly the same value. It's because they add up to 90. Same thing from here. Two different angles, they both add up to 90, so they both have the exact same value. This is what cofunctions are. If we look at other ones such as tangent, so tangent of 30 degrees should equal cotangent of 60 degrees. So let's go to cotangent to 60 degrees. There they are. They match. These are cofunctions. If I look at, let's do secant of 30 degrees. That should match the cosecant of 60 degrees. And there it goes. So these two match as well. Those are going to be our cofunctions. And when you look over here, you're going to see that the two angles always have to add up to 90 degrees. And these two are going to be together. So sine and cosine are referring to the exact same side. Tangent and cotangent are referring to the exact same sides. And then secant and cosecant are going to be referring to the exact same sides. Okay, so here's your example. If you have sine of 30, it's going to equal to cosine of 60. The two angles add up to 90 degrees, always. Okay, if you're looking at radians, the angles have to add up to pi over 2. Remember, pi over 2 is the exact same thing as 90 degrees. All right, let's go ahead and go on to the next one. This looks hard. It's not. It says, given cosine of 75, find a cofunction with the same value. So what we're trying to do is look for this exact same answer. Well, it's a lot easier. We don't really care about what this ratio is. All we really care about is what the trig function and the angle are. So I'm going to say this is equal to, instead of saying cosine, cosine and sine are together, I'm going to use the other one, which is sine. Okay? I'm going to take my 90 degrees, since this is in degrees, and subtract the theta that's over here. So I'm going to say 90 degrees minus 75 degrees. That equals sine of 15 degrees. Okay? That's your cofunction. Okay? So don't make it out to be harder than what it actually is. All right, let's go on to the next one. Okay, this is going to be a really much shorter lesson than the last two. Let's go ahead and do this one. This is going to be important when we get to Unit 3, but we're going to start it right here. It says, use the function identities to determine if the expression is true or false. If the statement is false, provide a counterexample. All right, we don't actually have to do this part. We're not going to do it at all. We're just going to start practicing this because this tends to be one of the harder things in the future in Unit 3 for most students. Okay, so let's go ahead and do this. Cosecant squared. All right, so in order for us to do this, we need to know what cosecant is. If you remember what the reciprocal of cosecant is, you should remember that it's sine. So I can actually say this is 1 over sine squared theta. Since I have 2, I need to make sure to include 2 here. These are the exact same meanings. What does tangent of theta mean? Tangent is sine theta over cosine theta. And then we have a sine theta. So I'm going to put sine theta here over 1. I'm doing this because I want to make sure everything on the top matches everything at the bottom. And then I have a cosine at the end. So I'm going to go ahead and put cosine theta over 1. And I'm asking, is that equal to 1? So let's go ahead and cancel everything out. I have 2 signs at the bottom. I have 2 signs on the top. These will all cancel. I have a cosine and a cosine on the top. That's the same thing as 1. So 1 equals 1. My answer is yes, it's true. Okay? Yes, it's true. Let's go ahead and do the other one. Tangent. Tangent, well, we said that was sine theta over cosine. Cosine, I'm going to put cosine theta over 1. And it's saying it's equal to 1 minus cosine theta. And we're going to check if that's true. Well, our cosines definitely cancel. So does sine theta equal 1 minus cosine theta? Okay. Hopefully you can see that this is not the same. This is going to be a no. Let's go back and look at our identities, because some of you might be like, it looks familiar, but the problem is it's not the exact same. I could use this Pythagoras identity and rearrange it, but it still wouldn't be what we have over here. Over here, these trig functions are not squared. Over here, these trig functions are squared. So even if you move the cosine to the other side and subtract it, cosine from both sides, it's still not going to square it. So these are not going to be the exact same values, and you just put no. Okay, we're not doing the counterexample. All right, let's go ahead and look at the last 2 problems. Number 6, a 28-foot slide at a water park makes an angle of 60 degrees with the ground as it descends into the pool. All right, so we're just going to do it like this. This is going to be 60 degrees, 28 foot, so that's going to be the length of the slide. Okay, and then here it's 90 degrees. All right. What is the vertical distance from the top of the slide to the ground? So it wants to know what this is. Okay, I'm just going to name it H, So it's saying, what is the height? Okay, so if we look at this one here, which trig function can we use? In this particular case, we can go ahead and use sine, because sine is opposite over hypotenuse. So I'm going to say sine of 60 degrees equals h, which is opposite, over hypotenuse, which is 28 feet. Okay, so now I'm going to go over here and say, can I solve for h? Well, yes, go ahead and multiply everything by 28 feet so that this cancels, and we're left with h is equal to 28 feet sine of 60 degrees. Let's go ahead and use our calculator for that. And it doesn't say how many decimal places, but we're going to go ahead and round it to just the nearest foot. So I'm going to go ahead and make sure, number one, make sure your mode is where it's supposed to be. We need to be on degrees. This is in radians. This is one way to get this wrong, is if you don't check your mode every time. So we're going to go ahead and go to degrees, and I'm going to put 28, and then I'm going to put sine of 60 degrees. Okay. You don't have to put the little degree sign, but if you're in radian, you would, and you would get the correct answer. Okay, so this is approximately 24 feet. We're going to only round to the nearest foot. So 24 feet is from the distance from the ground to the top of the slide. All right, let's go ahead and do number 7. An observer on a roof has a 40-foot building measuring the angle of depression from the roof. Okay, so an observer is on top of a roof of a 40-foot building, so I'm going to go ahead and put 40 feet here. And he's using the angle of depression. So angle of depression, if you're on top of the roof, angle of depression will be the angle between horizontal line looking down. So that's going to be our angle. Okay, it says the angle of depression from the roof to a bench is 24. So we're saying that this is 24 degrees. If this is 24 degrees, so is this. This is going to be 24 degrees. We have to go back to geometry and talk about alternate interior angles. You probably remember hearing that in geometry in high school. Okay, so then it says, what is the distance from the base of the building to the bench? So what we're looking for here is this distance. I'm going to call that D. Okay, so if we have this angle and we have this side and we have this, which trig function should we use? Well, how about tangent? Tangent of 24 degrees is going to be opposite, which is 40 feet, over adjacent, which is D. Okay, so in this case, notice that the denominator is unknown. So we're not going to multiply by 40 on each side or divide by 40. We are going to go ahead and divide, or I'm sorry, multiply by D, so this comes out and goes into the numerator. Then I'm going to go ahead and divide by tangent of 24 degrees. Okay, that will cancel this tangent out, leaving D is equal to 40 feet divided by tangent of 24 degrees. Okay, notice that we still have a unit of feet, so our answer for D has to also be in feet. Let's go ahead and use the calculator for that. So 40 divided by degree mode, degree, good, tangent 24. Okay, I'm going to go ahead and close that, press enter, and we're going to round to the nearest foot, which makes this, that's an 8, so the whole number of feet would be 90 feet. Okay, so approximately 90 feet. All right, that actually does it. I told you it was a much shorter video than the last two. If you have any questions over this section, please send me an email and let me know. Thank you.